Good afternoon,
as low
everyone.
as
I'm
possible,
Guanyu
please.
Chen. Oh, okay. And I'm delighted to present our recent work. The system is called SmartVisor, a user-friendly hypervisor for mobile robots. I will take you through the key points of our research. Currently, the execution of robot tasks relies heavily on the support of operating systems. Deep learning, SLAM, and entertainment applications require the support of Linux, while RTOS is needed for hardware control. However, most existing operating systems struggle to support such different features at the same time. Linux lacks real-time capabilities, and RTOS is limited in its system functionality. Virtualization is a viable solution. Nowadays, most of hardware supports virtualization features. For example, the ARM architecture introduced exception levels to support virtualization. Considering these factors, we designed SmartVisor, a virtualization software platform for mobile robots. We list several mainstream hypervisors and classified their implementation architectures into monolithic kernels, microkernels, and standalone system software. For instance, PVM is a hypervisor developed based on Linux, while BAO is a standalone hypervisor. It can be observed that hypervisors based on microkernels are still rare. However, microkernels provide strong isolation and basic system functionality, making them a balanced and ideal choice for hypervisor implementation. The trend in designing robot systems has shifted towards adopting mixed criticality systems, which utilize multiple kernels to execute tasks with different criticality levels. The MCS refers to the integration of computer hardware and software capable of executing applications with varying criticality levels. Considering the significant costs associated with development and maintenance, virtualization is a good way to construct multi-operating system environments. The hypervisor ensures partitioning and isolation of each operating system. In our work, we also considered the requirements of MCS and designed SmartVisor to meet these needs. With SmartVisor, we can manage multiple operating systems and ensure their appropriate partitioning and isolation. Our goal is to provide a user-friendly hypervisor platform for mobile robots that supports the execution of applications with different criticality levels. During the deployment of the hypervisor on actual robots, we encountered several challenges. Slow boot speed, difficulty in updating the system, and low reliability were common issues we faced. To make SmartVisor more user-friendly, we developed a virtual machine management module to address these challenges. The architecture diagram of SmartVisor illustrates the various modules designed to support the operation of multiple virtual machines. The multi-VM support module enables efficient collaboration between virtual machines. The driver support module provides service to the VM management module, and the VM management module manages the state of virtual machines. To tackle the startup issue, we implemented a partial init scheme by prioritizing components with fast startup, such as the RTOS, and utilizing page allocators to meet the demands of large pages in Linux. We significantly reduced SmartVisor's startup time compared to the original SEL4 system. In terms of file loading, we incorporated local file reading and remote file downloading capabilities into SmartVisor, enabling different access to the image files. For monitoring, we proposed a hybrid core monitoring scheme, where the small core monitors the large one. Additionally, we implemented a backup system to ensure recovery in case of failure. The state transition diagram for recovery shows that the backup system can be activated regardless of the success or failure of the recovery process, providing essential service support. Moving on to the experiments, we conducted system experiments on the RoboKit using the NVIDIA Jetson NX. SmartVisor will run a guest Linux and a guest TOS at the same time. To evaluate virtualization performance, we compared the benchmark scores of bare metal Linux and guest Linux using Unix Bench. The results indicated that the SmartVisor incurs approximately 30% virtualization overhead. Additionally, we observed that the allocation of 2 MB pages has a more significant impact on system performance than 4 KB pages. We examined the system's boot overhead by comparing the optimized system with the original SL4 hypervisor. We observed a significant reduction in startup time, except for the initialization of the SL4 kernel. The optimized guest Linux startup time was measured at 17.9 seconds, while the TOS startup time was 14.3 seconds. Furthermore, we conducted experiments in which the RoboKit running SmartVisor was deployed in an underground garage. The resulting point cloud map shows the robot's fundamental capabilities. To test the system's recovery capability, we intentionally caused a crash in the guest Linux. The SmartVisor will detect the issue and initiate the recovery process, as demonstrated in the accompanying animation. SmartVisor successfully recovered from the crash, resuming normal operation within 30 seconds. In conclusion, our work presents SmartVisor, a user-friendly hypervisor platform based on a microkernel architecture for mobile robots. We addressed the challenges related to slow startup, difficulty in updating, and low reliability through the design of the virtual machine management module. We successfully deployed SmartVisor on a mobile robot and thoroughly tested its core functionalities. Thank you all for your attention and patience. If you have any questions, please feel free to ask.
Okay, thanks. Any question? Also, I have one. So it seems that your SmartVisor is not limited to mobile robots. Right? So what is the reason that is limited to mobile robots in your study?
Sorry?
So the title mentions that this is for mobile robots, right? The SmartVisor. Yeah. But in fact, it's a general solution. Am I right? Not only limited for mobile robots. Especially you did not actually have special considerations about robotics in the hypervisor part. Or did I miss anything? What is the limitation? What do you actually limit the scope to mobile robots?
When we deployed first we used the SL hypervisor and deployed it on the mobile robots, but we meet some issues such as boot slowly, to update, and low reliability. So we optimized the original hypervisor and make it and design the SmartVisor.
Do we have further questions?
Some modules.
Sorry, do we have further questions? If not, then let's thank speaker.